Okay, by now you know a lot about modules, and I thought in this video I would show you a few ideas of things you can do and things you shouldn't really do. Here are a few things you can export from your module. You can export variables, functions, classes, function templates, class templates, and concepts, and all these little entities that you would really like to access from other parts of your application. You can't export entities with internal linkage. And when we talk about internal linkage, think about the static keyword that we have seen earlier in the course. Think about anonymous namespaces. These are things that allow you to constrain things inside a translation unit. And if something is constrained to live inside a translation unit, you really have no business exporting it. If you do that, you will get a bunch of compiler errors. You can only export things that live at the namespace level. So, for example, you can't export something that lives inside a class. If you try to export a class member, you will get a compiler error. Another thing you should keep in mind is that template code should really live in a single file, so it should be part of a single module interface file. If you try to split things around, you will get weird compiler errors, and you should really avoid that. That's my personal experience that I am sharing with you here. Here is a piece of code that shows these ideas in code here. So for example, here on line 6, we have a namespace and it doesn't have a name. So it is an anonymous namespace. And what this means for C++, it means that anything inside this namespace is going to be constrained to this translation unit here. So if you try to use this add function outside this translation unit, you will be in for a bunch of compiler errors. And the reason is that the add function has internal linkage. It is meant to be used inside this translation unit here. Another way to mark something for internal linkage is to use the static keyword. Again, line 10 here is setting up this version variable to have internal linkage, and it should be constrained to this translation unit. If you try to export it, you will have a bunch of compiler errors. Another thing that is obvious is that you shouldn't really export members of classes. You made them members of a class for a reason, so they shouldn't really stand by themselves. If you export them without exporting the class that englobes them, this is going to lead to compiler errors. You shouldn't really do that. This is the idea here. Here are a few things you can do, however. You can export a function template like we are doing here. This is inside an export block. You can export it using the syntax here, export template type name. You can set up a concept and export it by exporting the template declaration here. This is going to make it available for use in other translation unit. You can export a version which is not marked for internal linkage. You can also export a class like we have seen earlier. These are things you can do, and these are things you can't do. Make sure you keep this in your mind as you build your own C++ modules. Now that you know this, we can head over to our IDE and see this in action. The code that we use is going to be coming from this project in our GitHub repository, do's and don'ts. We have two files, the math interface file, which contains things we do, the math interface file, which contains our module. So let's copy it and come back to our IDE and create the interface file, which is going to be local to our system here. So math.ixx, we add it and we put in the code. Okay, and we can go back to the GitHub repository and grab the main CPP file. Copy it and put the code inside the main CPP file here. Remove whatever we had in and put in the new code. Because this is using C++ 20 modules, we need to make sure we enable C++ 20. We do that by coming to properties, going to language, going to the C++ standard here and setting this to 20. And we can go to general and scan sources from module dependencies. We want to enable this. Let's say yes, apply, okay. And if we try to build now, let's see how this goes. This is going to build successfully. Let's go back into the main CPP file and see what we have. The main CPP file is importing our math module. It is going to try and use an exported concept. You see multipliable here is a concept that we have exported. We can use it. We can add two numbers using the add function. We can set up two characters and try to add them And we can try to print the version from the math module. So these are things that we have exported, and we can export them and use them. Okay, you can see the function template here. You can see the sub function here. You can see the concept that we define here. All these links are working nice, as you have seen. But if we comment this out and try to do the things on top, so let's do this and uncomment the code on top. I want you to see these errors. Okay, so you shouldn't really do that. And go to main.cpp and what can we do here? Let's comment out everything. And we can selectively enable things that we want to see. We'll see how this goes. So we are just, and let's comment out the code that tries to use this concept, because we don't know how this is going to play with the new code that we are enabling in our module here. So we have this kind of thing. You see, we have the module. We have a function which is marked for internal linkage because it is living inside an anonymous namespace. So this is going to blow up. We can't export this. We can't export a static variable because it is marked for internal linkage because of the static thing you see here. We can't export a member of a class. If we try to do this, we will get weird compiler errors. So let's try to do that. I will show you the compiler errors for Visual C++, but if you want, you can try to compile this code with any of the compilers, and the instructions are shared here, and you will be in for a lot of errors if you try to compile this code here. But if you take out these offending lines, so let's go down and comment this out. Don't do this. We shouldn't do this. So we are commenting this out. We are bringing in the code that works, and let's make sure we enable this. Come back to the main CPP file and enable our things. So let's do this and bring this in. Now, if we try to compile, this is going to work. So let's build a solution. We see the build is successful. If you try to add two strings, let's see the myAdd function. MyAdd function is going to constrain the parameters to be multipliable, and strings aren't multipliable, so you can't multiply pointers as we have here. And if you try to do this, let's see what you have. Okay, if you try to do this, this concept is going to fail. So let's build again and see what we get. Okay, and it is going to give you a bunch of errors. One of them is going to be the associated constraints are not satisfied. The concept multipliable evaluated to false. You can't multiply two strings, so you can't use this function with const char pointer strings as we are trying to do here. This is something I want you to see. This is really all I had to share in this lecture. Again, if you want to compile this with GCC and Clang, you already have the commands to do this. Fire off a few terminal windows on your system and try to run these commands here and see the errors for these compilers if you happen to need that. I am going to stop here in this video, and I will see you in the next one.